the concentration of the water will be raised on the power of 2 because there we have two water molecules interact between each other. So it's experimentally and theoretically proved that the concentration of the water rise on the power of 2 is equal to 55.56 mole per liter, and the concentration of the value of the Kc for this process is equal to 1.86 multiplied to 10 raised on the power of minus 16. So when we multiply these two values, we obtain the value for the new constant, which we obtain when we multiply the constants, called autoionization constant of the water, expressed Kw. And as I told you, the values of every one of these components, we obtain that the value of Kw is 1 multiplied to 10 raised on the power of minus 14. So pay attention, that is very, very important. You must remember that the value of Kw is equal to 1 multiplied to 10 raised on the power of minus 14. So how it will look like the equation Kw? Concentration of hydronium ion multiplied to the concentration of the hydroxyl ion has a value of 1 multiplied to 10 raised on the power of minus 14. When we know this relationship and that value, and because the concentration of the water, we always, when we have the concentration of one of these ions, we always can find easily the concentration of the other one. Why? The water is a binary component. It's not possible to produce a hydronium ion if it's not produced a hydroxyl ion, because hydroxyl ion is produced when one water molecule donates one hydrogen cation, and the other molecule will accept that hydrogen cation, producing a hydronium ion. So these two, the creation of these two ions are connected. Do you have any questions until now? Is it clear?
Yes.
Okay. Let's see. As we can see, all these equations are connected. It's not possible to speak for base without speaking for acid, and oppositely. For that reason, let's present the concentrations of acids and base when they interact with each other. What will happen if we multiply these constants? That when we have action multiplying, we can make our equation simpler when we remove the same values. And what happened, what left? That when we multiply Ka to Kb, it will be equal to what? To Kw, the autoionization constant of the water. So from that here, we obtain also the relationship between these two constants, which when we multiply them, we will obtain also Kw. And what we know for Kw, that has value equal to 1.1 multiplied to 10 raised on the power of minus 14. So with this relationship, also, when we know one of the value of these constants, we easily can find the value of the other one. But what is the relationship between all of these and pH? Until now, I think it's very simply and logical, everything, but to be honest, it's not very easy to be calculated because, as you can see, we speak about very, very small values. For that reason, one that science called Sorensen proposed to work not with the concentration, to work with their logarithmic values. It means he proposed to multiply all of these to negative decimal logarithm. So let's see what will happen. And when we calculate, just before this I will show also. And when we calculate this, we obtain that pKa plus pKb is equal to pKw. For the second equation, we obtain that pH plus pOH is equal to pKw. And what we said about pKw, Kw is equal to has value 1 multiplied to 10 raised on power of minus 14. And when we calculate this, we obtain that pKw is equal to 14. So, from all of these that we write here, we can obtain the important one, very, very important relationship, that pH plus pOH is equal to 14. So, is it clear?
Yes.
Yes. Do you have any questions until now?
No.
Okay. Then, let's see how this help us to find out the pH value of one solution. For example, just I want to remind you, it's very, very important. Pay attention. A huge nota bene. Concentration. Concentrations present like this. pH and pOH with whole value. Right? Pay attention. Make a difference when we speak about concentrations, when we speak about logarithmic values. Without this, I'm sure that Professor Stoyanova told you, but without this, you won't take the chemistry exam. You won't pass the chemistry exam.
Okay.
Okay. Now, let's make some calculations. For example, I will give you one problem and we'll give you a few minutes to try to solve it alone to see is really everything clear. We have hydrochloric acid with concentration 0.01 mole per liter. Find out the concentration of hydronium ion, hydroxyl ion, pH, and pOH for that solution. Solve this.
Professor,
I'm listening.
I I can't see what does it say in the beginning? 0.01 mole.
Mole per liter, that is the concentration, molarity concentration.
Yes, okay.
Okay.
And then HCl.
Yeah, of hydrochloric acid.
Okay.
Are you ready?
Yes.
Okay. Now I will unlock the screen and I want some of you to write down the solution. Okay, but I have one question. How, from hydroxyl anion with concentration 1 multiplied to 10 raised on the power minus 2, you obtain POH 12? This is not true. The concentration of hydronium ion is 0.01. 1 multiplied to 10 raised in power of minus 2. Khavishit, this is correct. Yeah. Is it clear for everyone? Why is this?
Yeah.
Okay. Now, let's solve one other problem. This time we have 0.1 molar dissolution but of sodium hydroxide. Again, I want from you to calculate concentration of hydronium, of hydroxyl, pH, and POH. Are you ready?
Yes.
Yeah.
Okay, I'll unlock the screen, so write down the solution. This is correct, everything else is correct, just this one is not correct. Yeah, now it's better. Okay, any questions do you have?
No.
Then let's solve one a little more difficult problem. First, you have 4 grams sodium hydroxide, and they are dissolved in 1 liter solution. Find out the molarity concentration, and after that find out the concentration of oxonium ion, of hydroxyl ion, of pH, and pOH. Solve this one. Are you ready?
Yes.
Yes.
Okay, I will unlock the screen so you can write down the solution. Write down how you find out the concentration. Any questions?
No.
So now we must pay attention on this that pH can be calculated only during normality concentration, molarity or normality concentration. We cannot use percentage concentration. For that reason, I want to see how we can move from percentage concentration to molarity concentration. Find out what will be the percentage concentration of this 0.1 mole per liter sodium hydroxide solution. What will be the percentage concentration of this solution?
Isn't it going to be 4% because it was in 1 liter of solution? 4 grams in 1 liter of solution.
Write down. It's unlocked. Absolutely correct. Yeah, correct. So, as I saw, for now, until now, everything is clear for you. But now we must say that this will be valid only when we speak about strong and strong base. And the reason of this is because when we speak about strong protolyte, the dissociation is full. But when we speak about weak acids and weak base, for example, one example for weak acid is the most common, the most used acetic acid. What will happen when we speak about, when we want to calculate the pH of one solution of weak acid? Weak acid will react again, will represent it with water. What we can say about this interaction? It's reversible reaction. So the dissociation is not full. And for that reason, we cannot use the method until now for calculating the pH of the solution for one weak acid. So let's represent Ka again. For this case, generally, we'll divide the concentration of the acetic acid. When we speak about acid reaction, generally, we can say that we can replace the concentration of the acid just with concentration of any weak acid. And can we say that the concentration of the acetic anion is equal to the concentration of hydronium ion? Yeah, it's equal because every acetic anion is produced because donate a hydrogen ion to hydronium. So we can present it just with concentration of hydronium raised to the power of 2. What we obtain and because we speak about pH and to remove that power 2, we can represent it like this. Because we are given for very small digits, we must multiply all of these to negative decimal logarithm. And that will be equal to pK. A will be equal to P of, I'm sorry, pH is equal to pCa plus pKa divided by 2. This is for acid, weak